Finding increasing and decreasing intervals in relative extrema using the first derivative test. You need to understand these key terms to solve the problems. Relative extrema are points of a function that are either a relative maximum or minimum. Increasing intervals are where the function has a positive slope. Decreasing intervals are where the function has a negative slope. The first derivative of a function gives the rate of change or slope of the function. Critical values are independent values where the derivative equals 0 or is undefined. To identify the extrema, you need to construct a number line. Take the derivative of a function. Find critical values for all defined intervals. Place critical values on a number line. Test values where the original function is defined in each interval and the derivative separated by the critical values. If the result is a positive value, it is increasing. If the result is a negative value, it is decreasing. Identify critical values as maximum, minimum, or neither. Plug values where extrema occur back into original function to obtain the dependent coordinate. There are patterns to recognize to identify a maximum or a minimum. A critical value preceded by a decreasing interval and followed by an increasing interval is a minimum. A critical value preceded by an increasing interval and followed by a decreasing interval is a maximum. Identifying extrema continued. A critical value surrounded by decreasing intervals is not an extrema. Critical value surrounded by increasing intervals is likewise not an extrema. Example number 1. Find increasing and decreasing intervals of the given function as well as relative extrema given f of x is equal to negative 3x to the 5th power plus 5x to the 3rd power. First, take the derivative of f of x, resulting in negative 15x to the 4th plus 15x squared. Factor the first derivative to identify critical values or the zeros of the derivative. The derivative in factored form is negative 15x squared times the quantity of x plus 1 times the quantity of x minus 1. The critical values of the function are negative 1, 0, 1. Test intervals in derivative for positive or negative slope. Identify all maxima and minima. Remembering the derivative in critical values, we construct a number line with the intervals separated by the critical values. Because the original function has an unrestricted domain, we test all intervals. Test values from these intervals in the first derivative to determine whether the interval is increasing, decreasing, and mark it as such. The first is decreasing, the second is increasing, the third is increasing, and the fourth is decreasing. Our rules for extrema show that a minimum occurs at negative 1 and a maximum occurs at 1. Notice how nothing occurs at 0. Plug in critical values where extrema occur into the original function to obtain the coordinate of extrema. F of negative 1 is negative 2. F of 1 is 2. Example 1 solution. A maximum occurs at the point 1, 2. A minimum occurs at the point negative 1, negative 2. The function is increasing in the interval negative 1 to 1. The function is decreasing in the interval negative infinity to 1, union 1 to infinity. This can all be verified by examining the graph below. Example number 2. Find the increasing and decreasing intervals of the given function as well as relative extrema. Given f of x equals the quantity of x squared plus 25 over x. First, take the derivative of f of x using the quotient rule, resulting in x times 2x minus the quantity of x squared plus 25 over x squared. Simplifying the first derivative results in a quantity of x plus 5 times the quantity of x minus 5 over x squared. We find the critical values of the function to be negative 5, 0, and 5. Example 2 continued. Test intervals in the derivative for positive or negative slope. Identify all maxima and minima. Remembering the derivative and the critical values, we construct a number line with the intervals separated by critical values. We test the intervals in the domain of the function. Test values from the intervals in the derivative to determine whether the interval is increasing or decreasing, and mark it as such. The first is increasing. The second is decreasing. The third is decreasing. And the fourth is increasing. Our rules for extrema show that a minimum occurs at 5 and a maximum occurs at negative 5. Nothing occurs at 0. Plug in critical values where extrema occur into the original function to obtain the coordinate of extrema. F of negative 5 is negative 10. F of 5 is 10. Example number 2 solution. A maximum occurs at the point negative 5, 10. A minimum occurs at the point 5, 10. The function is increasing in the interval negative infinity to negative 5, union 5 to infinity. The function is decreasing in the interval negative 5 to 5. This can all be verified by examining the graph below.